Section 7.3. So 7.1, we learned about the law of sines. 7.2, we had the special case with the law of sines, where I was giving two sides and an angle, and I needed to calculate the other angle. And when I do, I get into that ambiguous case. So I had to be careful when I was setting that up. Today, there's another, we're going to start with another fact to put in our inventory. And that fact is the triangle length restriction. And once I say it, all of you are going to go, yeah, that kind of makes sense. And that is any two sides, if I take them and I add them together, they must be greater than the third side. And if you look at the little drawing here, kind of makes sense. I couldn't come up with angles, these dotted lines, unless these were definitely long enough to touch. Well, and if this is 10, 3 goes to there, 4 goes to there. These two guys would never touch no matter where I swing them. So something to keep in mind, any two sides have to be greater than the third. Any two sides have to be greater than the third. So there's all this fun and games like we did with the law of sines. If you remember, how did we come up with the law of sines? Well, we took a triangle and, I had just a random triangle, and we dropped H, and we said, if this is A and this is B, and we looked at the sine of A was yada, 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 sine of B was yada, 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 and then we had H in both of those. This is little b, this is A, this was little c. But when we said the sine of A, we said, okay, that's H over B. And when we said the sine of B, that was H over A. And if we got the H's alone and set them equal to each other, did little work, it's where the law of sines came from. Well, there's a way to calculate this next group, the law of cosines. But I think if I started on that in the 10 minutes it would take me to demonstrate it, I would lose half of you. You'd be going to grab a glass of iced tea or something like that. So I'm just going to give you the law of cosines. And the law of cosines should look a little bit familiar to you, because if I covered that right part up and all of a sudden a squared equals b squared plus c squared, that goes right back to looking at the Pythagorean theorem. That means, yeah, if I'm looking at this triangle and angle A was actually 90 degrees, it's not, because we're not using right triangles in chapter 7. But if it was 90 degrees, the cosine of 90 degrees is 0. All of that would be gone. And A would be my hypotenuse across from the 90 degrees. So this looks kind of familiar. So when we're learning it, using it, you'll be able to come up with it. Yeah, a little bit like that other formula we had the other day to find area. It was the 1/2 base times height, but then we replaced height. So it was 1/2, then it was something like AB sine of C. We had a formula for it, and it used a little bit of everybody. Well, this is using a little bit of everybody. In fact, in order to do this, you can see I need either 3 sides. Like if I'm given A, B, and C, I can find A. Or if I'm given an angle and 2 sides, like B and C, I could find A. Or if I was given A and B, I could calculate C. So, yeah, given certain pieces, I can finish the triangle. I can complete the triangle. Well, let's jump right in with an example. And as you see, okay, I have A, I have little b, and I have angle C. So what I'm going to be able to do is use this third formula. I'm given angle C. Can I come up with little c? Well, let's see. C, yeah. So A is 423. B is 259. Little c, big A, I don't know. Big B, I don't know. Big C is 132. And I already know this is 0.66. degrees. Okay, 40 over 60 is 2/3, so 0.66. So when I look at this, I'm going, oh man, I can't use the law of sines because I need an angle A or angle B. So with what I'm given, I now am okay, I'm going to use the law of cosines. And knowing angle C, I'm going to use this third one. Unfortunately, and I'm given A and B as well. So I'm going to pause this recording because I don't need to hold your hand and go through this step by step. I'd rather you give it a try on your own. Calculate little c. That's all I want right now. Paused. Okay. C equals
203.
203. Everybody like that answer?
That's not what I had.
What'd you get?
I had 628.1.
I also got 628.1.
Uh-oh.
Oh, now I missed count ones.
Okay.
Oh, never mind.
Let's see what we have. 628.1 sounds like popular choice. C squared equals 423 squared plus 59 squared minus 2 times A times 259 times the cosine of 132.40. On calculator. Oh boy. 423 squared plus 259 squared minus 423 times the 259 times the cosine of, oh boy, I hope I have it in degrees. I didn't check before I started. 0.40. I'm sorry, that's 42. Back. Second apps degrees. And then I want 40 apps minutes. And I hit enter. Oh boy, some crazy number. 320,260.285. I need to take the square root of that.
Professor,
Yeah.
you didn't put 2.
Ah. All right, so I can do that. I know that there's a way to get last. Second what? Second enter. Hey, look at that. Baka. Times 2, which would really make this 846. Thank you. I did that on purpose. 394, does that help? Is that a better answer?
Yes.
Yeah.
Okay. Good. 394, 510. 394, 510.5693. And now I want to do square root. So it's second, that guy right there above the x squared. Second, down here at the bottom is this minus, which gives me the answer. And if I hit enter, I get 628.1. Okay, and that's the answer we got right here. So I just used the law of cosines, and I'm going, cool, there's the law of cosines. My next step would be the law of sines to come up with B. Again, I would be careful for an ambiguous case because you see what I'm given. Once I find B, I'd use the sum of 3 angles is 180 to calculate A. We've been practicing that recently, so I'm not going to keep going with it. I just wanted to practice the law of cosines and see if you didn't screw it up like I did. Cool beans? I'm going to pause, and I'm going to put you in groups, give you a couple minutes to work on these. Please chit chat in your groups, making sure, even if it's as simple as, okay, we need to find, calculate little a, and did anybody get this? Did anybody get that? You know, you don't have to be like best friends forever, but that's what I kind of like you to. Okay. If you got the answer to this problem, funny thing is there's actually two sets of answers. If you all got this in your group, fantastic. Unless I goofed up somewhere. Let's run through it real quick. I was given A, angle A, side B, side C. So I used the law of cosines. I filled in the work. Boom, boom, boom. I got A equal 10.474. Did I do that right?
Yep, got that.
Got that. Okay, good.
Yeah.
I don't want to keep going and then somebody say, by the way, I didn't get little a, I got something else. And I'd be going, why didn't it? Anyhow, good, boom. So now that I have little a, I'm going, okay, I'm going to use these four and solve for B, angle B. Well, actually, I did angle C, I'm sorry. So angle C, I'm using the law of sines and I'm going, hold on, Bubbaloo. When I'm doing the law of sines and I'm going to get two answers. So I did a little calculation there. I got 0.99. Angle C is 81.9 in the first quadrant, 98.1 in the second quadrant. Anybody else get that?
Had the first value, we forgot to find the second.
Okay. So once you have the first value, now I have C and I get ready and I go ahead. I found side A, angle C, and of course, angle B is the difference in those. Now I come back down and I deal with the 98.1. So I use that to find angle B, 180 minus those two. And then from there, I use the law of sines to find little a. What you think about that? I'll wait a couple seconds in case, as Tomas said, that they had to do this. Kelsey, did you get both sets of answers?
I did not get both sets, no.
But now you see it and you go, oh,
Yeah.
I should have. Okay, good. Good. Like I said, you got all this, you understand all this. You're up through section 7.3 with flying colors. You're going to nail this test. That's right, nail it. That's what I said. Okay, I didn't go very far on the next one because we'd be beating a dead horse. But to set up this problem, I am given A, B, and C, the three sides. With the law of cosines, I can now find angle measures. And as you can see, I found a value for 65.094. Hopefully somebody else is going to go through this or already did. A squared equals B squared plus C squared minus 2BC sine of A. 0.947 squared, 15.9 squared, 21.1 squared minus 2 times BC sine of A. I got a value. That looks right. That looks right. That looks right. That looks right. I subtracted the 252. I subtracted 445. I then divided by negative 670.98, and I got 0.907 for sine of A, and I'm like, yay. Oh, I'm almost there. Sine of 0.907 is 65.04 degrees. And then from there, you got yourself some law of, son of a gun, what'd I do wrong, folks?
Professor?
Yes, go ahead.
Okay, that's what I was about to ask. But we're
Yeah,
using sine instead of cosine.
what the heck was I doing? Too much iced tea. The dog distracted me. This is the cosine of A, folks. The cosine of A, the cosine of A, the cosine of A, the cosine of A, the inverse cosine, and I'm gonna clearly get a different value here. Sorry about that. I knew I'd do something wrong. That's why we went over this. The inverse cosine of that. Oh, and the inverse cosine. I was rushing. Of 0.907 equals 24.906 degrees. 24.906 degrees.
But, Professor,
Did I mess up again?
how did you come about your 0.907?
I took -608 and divided it by -670.98.
I'm still confused about, because I know at the end of the day, I had 89.6809 equals 27.04, then cosine A.
Okay, so let me go back and check. Let's see, okay. So sports fans, A squared is 0.947 squared.
Yeah,
And do you agree with 89.608?
perfect.
15.9 squared is 252.81.
Okay,
21 squared is this,
yeah,
and 2 times 15.9 times 21.1 is my 670.98.
okay, yeah,
Okay, so now I'm going to subtract this. So 89.6809 minus the 252.81. Then I'm going to also subtract 445.21. And when I do that, I get this -608.309.
okay,
So I subtracted this and I subtracted this, and I let this term alone, -670.98.
okay. That's not what I did was that I go straight ahead, 252 plus 45 minus that.
No, this is tied with A.
Okay,
So
okay,
really
okay.
so what this is something that would look like this. 11 equals 4 plus 2 minus 3x. Yeah,
Okay.
you would bring the constants over, and then
Oh.
you would be dividing by -3.
Okay, okay. I think
Yeah.
that's
So if I
that's
make
right.
it clean algebra, that's what it would look like.
Okay. I think that's where I got it wrong.
Sure, no problem. You've corrected me. Let me help you. And again, I now would do the law of sines to find the measure of angle B. I would take 180 minus A and B to calculate the angle C. Okay, the other day, we finished 7.1 last week, and we did it with a formula to find area. I have a note before that though, 436, and I don't know that you need to use this or not, but if I take a look at page 436, you see a whole chart. What am I given? What should I use? And so forth. And I don't think you need to like have this written out. But there may be somebody that look at this on page 436 and say, oh, that really helps me. We looked at the situations of what we were given and what we can use. And we went to town. We knew if the very first thing I laid out was sine of A over the number A, sine of angle B over the number B for the side. If I'm looking at the sine of something right away, that's my ambiguous one, where I would have 2, 1, or no solutions. But there is a chart there, and I wanted to point it out because some of you may look at it and go, hey, I like that chart. Okay, finishing up 7.3, we have a second way to calculate the area. The other day, we did something along the lines of area equaled And it was 1/2 the base times the height. And the height would be, it always came out as something like C sine of A. Again, we were using all the pieces, BC and angle A, or AB sine of C. And we had a formula for whatever we're given, we could find the area. Well, today we're going to look at a second way to find the area. And this is when I'm given 3 sides of a triangle. Well, in order to do it, the first thing I need to do is calculate this value for S. And it almost looks like the average of the 3 sides, where I would take it and I would add them together and divide by 3, but I'm not. It's not the average. It's close. So Heron went and figured all this out and said, first thing I want to do is calculate a value for S. And then my area is going to be the square root of S times S minus side A, S minus side B, and S minus side C. So I'm not going to pause or anything. We're going to keep rolling here. So I'm going to start out with calculating S, 1/2 of 2451 plus 331 plus 2427. And as always, please play along so I don't mess this up and we get so far and we're going, oh no, 2451 plus 331 plus 2427 divided by, whoop, that's time. I can do times 0.5. I don't need to divide it by 2. S 2604.5. Da, 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 da. Here come the younger up the road. Excuse me, next. Sorry. Somebody get that same answer?
Yeah.
Yes. Okay, good. S actually has a name, and while we're here, I'm going to put it down. S equals the semi-perimeter. Has no real meaning to me, but the first thing we need to do is calculate that S. Now, what's the area going to be? It's going to be the square root of this big mess. S 2604.5. 2604.5. And then it's going to be S minus 2451. Okay, so that's going to be 2604.5 minus 2451. And that should be 153.5 times S minus 331. 2604.5 minus 331. 2273.5. And finally, S minus C, 2604.5 minus 2427. I'm going to do quick estimates. 2,000, 5,000. That's a little over 5,000. Half of 5,000 is 2,500. So I'm okay with that number. There's 2604.5. That minus that is about 150. That minus that is about 2,300. That minus that. Okay. I think I like all of my calculations. Did a bunch of quick estimation skills. Second x squared is going to give me square root of parentheses 2604.5 times 153.5 times 2273.5 times 177.5. Somebody get an area?
Yeah, I got 401,664.11.
Sounds good to me. And if that's area, that's gonna be square something. Square something. All right, dog. Cool. The dog likes it. Just another way to find area. And this is kind of cool when I look at it. All right, I'm gonna yell at the dog. Questions? Questions? Dog has a question. Excellent. Okay, we have some time and not a lot. So I'm going to do a quick introduction to 7.4. And then on Wednesday, we'll pick up with the rest of 7.4. But this is just kind of, I don't even know that I'm going to be writing anything. It'll be me talking and you take the notes that you want to for this. All right, so following up with still working with triangles. Sometimes triangles are built, not triangles. Yeah, triangles, I said that, right? Are built with these things called vectors. And we're going to take a look at some vectors and then some simple application. The book gets into some that are kind of a little harder to do. But I think if you understand all the principles when you go to your major, because remember, math is a discipline that is like a sister discipline. So many of everybody else uses math in one way or another. So the applications can become really important once you leave me, hoping that you understand vectors and can start applications. But anyhow, what's a vector? A vector is a directed line segment. Way back when, we used to talk about something called a ray, R-A-Y, where it would start, it had an end point and then an arrow at the other end. You're really similar to that, but we're going to call these vectors. And as you can see, a simple description for a vector, it's a directed line segment. Okay, directed line segment. It starts at this initial point right here. It goes to a terminal point right here, and it has a direction. First of all, it has a direction. It's going that way. Now, how do we measure all that? Well, we can say that this has a length of 10, and we're going to switch terminology. Instead of calling it length, we're going to start calling it the magnitude. This guy has a magnitude of 10, and it also has an angle measure, in this case 30. So vectors can be all over the place, but a lot of times when we work with a vector, we're going to take it and throw it on the Cartesian coordinate system, and we're going to be able to work with it like we've done with triangles up to this point, where I start here and you know, I can put that height down and make a triangle and all, but we're going to talk about an angle measure of 30 and a magnitude of 10. So I mentioned a moment ago, we have an initial point and a terminal point. We can start doing some math with vectors. For example, the sum of vectors. Here's vector A, here's vector B. If I took B and put it over here on the end of A, where I end up is a point called A plus B. I have an opposite vector. Instead of going, for example, this guy 30 degrees, you know, if I was putting him on, it would be negative 30 degrees, going the opposite direction. Yeah, sorry, they should be more parallel looking. But instead of going this direction, my terminal and my initial and my terminal point are switched. Is basically what happens. These two guys up here, they do get switched. So if I came back here and said, what's A plus negative B? I would go A, then negative B would come this direction. And A minus B would be this vector. Special vector, the zero vector. It's one that has a magnitude of 0, has no direction, just a magnitude. Now, along with being able to add vectors, I can subtract. Instead of A plus B, I can do A minus B. Here's A minus B. There's the vector A minus B. Doing that, add and subtract, I can now also do something called a scalar product, where I take a scalar times it. Not really looking at multiplying two vectors, but I can have a scalar go and be multiplied against my vector. It doubles my magnitude. Same direction, double the magnitude. A little bit more. As I mentioned a moment ago, we can put it on the Cartesian coordinate system. And if I put the vector on here, say I have vector u, and you notice on the Cartesian coordinate system, its endpoint is AB. So now I'm going to be able to write this vector u in vector form, okay? And as you can see, it has a horizontal component and a vertical component, A and B. A is moving horizontally, B is moving vertically, but you notice we have these symbols, the less than and greater than symbol, to identify it as a vector. This isn't so bad. What's the magnitude of vector u? Da, 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 da. All this is if I set this equal to d, you go, hey, that's the distance formula. Remember, a squared plus b squared equals u squared. So if I want to find the magnitude, and you notice how I do the magnitude, I put it in what looks like absolute 0 bars, but it's not the absolute 0, it's the magnitude of a vector. And again, it's its length, it's its distance. You know, it equals d from the distance formula. It's our length. Now, what if I wanted to find the direction? Well, the direction is that angle measure. What is theta? Theta is going to be the tangent of b over a, because that's all I really know, b over a. So if I ever want to find the direction, so two big pieces coming out on this page. Yada da da da. The magnitude and the direction. The magnitude and the direction. The length and the angle measure. I'm only going to do one. I have two examples, but I'm just going to do this last one. What is the magnitude? What is the direction? What is the magnitude? What is the direction? We calculate these. Crisscross applesauce. That was a full day. That was a full day. Well, the magnitude is going to be 9 plus 4. A squared plus b squared. Take the square root of it. That's my distance. The length of this vector is the square root of 13. Tangent of theta equals opposite over adjacent. So if I drew this, my vector would be, oh, going the wrong way, sunshine. It would be 3, 1, 2, 3, -2. So it's to there. So I am in the fourth quadrant. This is 3, this is -2. The tangent is -2 over 3. Theta equals the inverse tan of -2 over 3. I better get an answer in the fourth quadrant. The inverse tan of -2 divided by 3. Theta equals negative 33.69 degrees. Whew. That definitely is in the fourth quadrant. All right, we have time. I'm going to do this last one. I think it's kind of cool. Given the magnitude and the direction, calculate the values for A and B. Okay, what is my horizontal and vertical components? A million times I said, if you're not sure, draw the picture. I'm drawing the picture. I have 41.7 degrees. I have 25. This is A, this is B. So I'm given this time, instead of the horizontal and vertical components, I'm given the angle measure and the length. I'm given, so this is going to be sine of 41.7 equals B over 25. And the sine of 41.7 equals A over 25. I got that backwards. That should be cosine, excuse me. And there you go. Swing that 25 around. This is the sine of 41.7 equals B. Swing that 25 around. So check it out. My B is 25, the magnitude sine theta. The other one is magnitude cosine of theta. Oh, oh, oh. The end is near. 41.7, 16.631. Could you imagine taking a whole test and your calculator's in radians instead of degrees? No, say it ain't so. 41.7 little a equals 18.666. Hopefully someone else got those answers. And you can see how these vectors tie into some of the other stuff we, excuse me, we've been learning up to this point. Sergio, any questions?
Not really.
Not really. All right, who else is on? Nathaniel, any questions?
No, I'm all good.
All right. Philip, any questions?